Based on the same concept, let us move on to the next question. Which of the following is paramagnetic? Vanadium plus 5, nickel 2 plus, option C, Mn 7 plus, option D, titanium 4 plus. Just now I said, if a transition metal ion is in its highest oxidation state, it does not have d electrons, it is repelled by the magnet, it is diamagnetic in nature. If a transition metal ion is in its lower oxidation state, it can have d electrons, it is attracted by the magnet. Amongst the given 4 options, vanadium is in plus 5 state, highest oxidation state of it. Manganese is also in its highest oxidation state, plus 7. Titanium is also in its highest oxidation state, plus 4. So, Mn plus 5, vanadium plus 5, Mn plus 7, vanadium plus 5, titanium plus 4 do not have d electrons. They are diamagnetic. While nickel 2 plus, which has 2 unpaired electrons in d, is paramagnetic in nature. So, the correct option is nickel 2 plus, option B. Let us move on to the next question. The question is, which of the following should be strongest reducing agent? We have standard reduction potentials of copper, iron, cobalt and scandium here. The correct options are, the given options are copper, iron, option C cobalt, option D scandium. We need to select a best reducing agent, strongest reducing agent. Reducing agent is electron losing species. Electron losing species has the lowest value of SRP. Look at the given values here. Copper minus 0.44, copper plus 0.34, iron minus 0.44, cobalt minus 0.277 and scandium minus 2.1 volt. Amongst the given 4, scandium has the least value of standard reduction potential. Lower the value of standard reduction potential, higher is the tendency to lose electrons and it acts as a strongest reducing agent. So, therefore, the correct option for this question is option D, scandium. Dear students, in the previous question, we had selected the best reducing agent, the strongest reducing agent. In this particular question, we need to select the strongest oxidizing agent. For selection of strongest reducing agent and oxidizing agents, students need to remember the concept of oxidizing and reducing agents. Remember, electron losing species is reducing agent, electron gaining species is oxidizing agent. Here, we need to select the strongest oxidizing agent. All are oxidizing agents, but the one which has more tendency to gain electrons is a best oxidizing agent. Chromium 2 gains only 2 electrons. Chromium 3 gains 3 electrons. Chromium 4 gains 4 electrons and chromium 6 can gain 6 electrons. Amongst the given 4 ions, chromium 6 can gain maximum number of electrons, 6 electrons. Therefore, chromium 6, which gains 6 electrons, can act as strongest oxidizing agent. So, the correct option for this question is option D, chromium 6. Now we'll move to a question related to magnetic properties of transition metals. Which ion has maximum magnetic moment? Option A, vanadium 3 plus. Option B, Fe 3 plus. Option C, Mn 3 plus. Option D, Cu plus 2. We need to select the ion having maximum magnetic moment. Remember, magnetic moment depends on number of unpaired electrons. This magnetic moment is given by square root of n into n plus 2, where n is the number of unpaired electrons. Amongst the given 4 ions, the ion which has maximum number of unpaired electrons can have maximum magnetic moment. Let us check the number of unpaired electrons in this. Vanadium 3 plus has 2 electrons, 2 unpaired electrons. Fe 3 plus has 5 unpaired electrons. Mn 3 plus has 4 unpaired electrons. Cu plus 2 doesn't have unpaired electron. Mn 3 plus has 4 unpaired electrons. Cu plus 2 has only 1 unpaired electron. So amongst the 4 options here, Fe 3 plus with maximum number of unpaired electrons, that is 5 unpaired electrons, can have maximum magnetic moment. So amongst the given 4 ions, the ion with highest magnetic moment is Fe 3 plus ion. Option B is a correct answer. Formation of interstitial compounds is one of the characteristic properties of transition metals. In this property, in the crystal lattices, that's in the interstitial site of the metallic crystal, the small atoms like hydrogen, carbon, boron, nitrogen can trap into the interstitial sites and form the interstitial compounds. And generally we call these interstitial compounds as non-stoichiometric compounds. Here, this formation of non-stoichiometric compound and interstitial compound is responsible for 2 properties of the transition metals. One is hardness and the other one is melting point. When an interstitial compound is formed, the hardness of the metal increases, automatically the melting point also increases. The next question is related to this property. Formation of interstitial compound makes the transition metal, option A, more soft, option B, more ductile, option D, more metallic, and option D, more hard. So as I had explained the interstitial compound formation which is responsible for hardness, automatically the correct option for this question is it is responsible for more hardness. So the option D is a correct option for this question.